Okay, this is kind of a fun problem. This is same page 499, and okay, now I talk to my pets all the time, but I never leave them messages on the answering machine. Okay, I'm not quite that wacky. Okay, so what I want to do is I want us to conduct this hypothesis test using a confidence interval. Okay? So let's try it. In a survey conducted by the American Animal Hospital Association, again, this is number 19, page 499, 37% of respondents stated that they talked to their pets on the answering machine or telephone.
Oh, wow.
Okay? And they admitted it. A veterinarian found this result hard to believe, so he randomly selected 150 pet owners and discovered that 54 of them spoke to their pet on the answering machine or telephone. Does the veterinarian have the right to be skeptical? Now, it doesn't say that, he just says that the veterinarian found this result hard to believe. So does that mean that he thinks that the proportion is larger or smaller specifically?
Smaller?
Now, no, this is before he collected his sample data. Okay? So he just found this result hard to believe.
Does not equal.
So does that tell us a lot about if he suspects that the proportion is actually a lot bigger or smaller? No. So what's our null?
Oh, that's not equal to.
Good. The proportion is equal to 37%. And in the alternative, we're going to put that the proportion is not equal to 37%, because he's not specific. They're not specific about, and this is part of it too, you know, we're kind of stuck with the information we're given, you know, about how to draw our conclusions or whatever.
But if he was skeptical, does that mean he thinks it's smaller?
We don't know.
Yeah, because skeptical could mean either way.
It could mean either way, right. So we're going to see if the proportion is just different in some way, okay? Either he's saying, no, I think my pet owners are a lot more crazy than that, or I don't think they're quite that crazy.
What happens if he
Okay.
said he doesn't have the right to be skeptical?
How
How would that change the problem?
would that,
Would that, they asked that question, does he have the right to be?
does he have the right to be skeptical? But again, that doesn't say in which direction. So that's just saying, does he have the right to say that the proportion is different than 37%?
Oh, okay. All right.
Yeah. So how many people did he sample? 150 pet owners. How many said that okay, so the attribute we're looking for here is people that say that they do talk to their pet on the telephone or answering machine. I know people leave their TV on for their dog. Do anybody who does that?
I do that.
Do you do that?
Yeah.
Okay.
All of it.
But some dogs really like human voices, I guess. Okay, how many people? 54? Okay. So our p hat, our sample proportion is x over n, or 54 out of the 150. And I'm not even going to bother reducing that. And note here it says use a 5% level of significance. So what I want to do, let's construct a 95% confidence interval for the proportion of all pet owners who talk to their pet on the phone or answering machine. Okay? Let's do that with our calculator. So we've got one prop z interval. Okay, you guys follow? Is this all right? And what are we going to look for in that interval? What are we looking for with respect to that interval? Somebody tell me.
We're looking to see if P falls within the interval.
The established P. Good, Ben. Good. So we're looking to see if that established P falls in the interval. And that'll tell us if the proportion is about the same, right? If the proportion's about the same, then we're going to get 37% in our confidence interval. If the proportion is significantly different, the 0.37 is going to be outside the interval. Paul?
Wouldn't it always be like the mean of that though, like the middle?
Excuse me?
Wouldn't it always be, when you do that 1 cross Z interval thing,
Uh-huh.
wouldn't the p hat always be the middle?
The p hat will always be in the middle
So it
because
always-
it's the point estimate.
Uh-huh.
So remember, the thing we're trying to capture in the confidence interval is what, gang?
The population mean.
The population
Uh,
proportion in this
Oh,
case,
yeah,
right?
yeah,
The
yeah.
population proportion,
Yeah.
okay?
okay.
And yeah, the confidence interval is based on the point estimate, which is p hat.
Yeah.
Yes, exactly. But let's go back and think about, do you remember how likely is it that the sample value is going to be the exact same as the population value?
Impossible.
Almost.
It's not going to happen, right? It's not going to happen. So remember, our confidence interval gives us a little bit more of a buffer of where we expect that population value to lie.
Yeah.
Okay? In the case of one parameter, all the hypothesis tests in chapter 10, you're testing against that established number. And that's going to change in the next section. Okay? Just a little bit. But, okay, let's go to 1 prop Z interval. Our number of successes is 54 in 150 trials. Confidence level 95. And calculate. So again, with the confidence interval, we're establishing that we're 95% confident that the population proportion, the proportion of all individuals who leave messages or talk to their animals on the phone, is between, looks like 28.3 and 43.7%. What do you think?
Yeah.
Okay,
Now we just need to
so
know what p hat is.
we are, well, p hat's going to be right in the middle of those, right?
1.36, okay, yeah.
Yeah, yeah.
Thanks.
So we are 95% confident. And it's also good, even if you feel like you're asking silly questions, or it's good to reiterate, because the more times you hear it, the better it's going to stick in your head. We're 95% confident that the proportion of all
Crazy people.
crazy people, so we
Yeah.
just write crazy
Yeah.
people? Crazy people is between, what would we say, 20.283 and 0.437, say? Okay, so what does that say about the what does that say about our HO? Are we going to reject HO? No?
No.
Why?
Between that.
If we're 95% confident that P is in here, and if that P is in here, then isn't it pretty likely that the true P is pretty darn close to that?
Yeah.
Does this make sense, everybody? You with me?
Yeah.
Could we survey the 54 people that talk to their pets on the phone and find out if any of them are clinically insane? To make inference about how many people talk to their animals that are clinically
Yeah,
insane?
and can I have a look-see through your medicine chest? Because it's going to be really interesting. Okay, so this would lead us to,
Is this a problem from 10.4?
it is.
Okay.
They said to just test at the 5%, but
You're going backwards for a
I'm
second.
asking, well, sort of, but can't we,
Yeah,
this is new stuff, right? But can't we establish this?
but are we gonna do the new stuff too? On this problem?
Okay, we can, sure.
Or are we just gonna
Yeah, we
use the
can, sure.
old interval to do this?
Well, I wanted to establish this first, but then we can go back and do it too. Okay, so we're 95% confident that the proportion of all crazy people who talk to their pets on the phone or answering machine is between 0.283 and 0.437. And this would lead us to do not reject HO. Why? Because the established percentage is in the interval. So I think the question was, does the veterinarian have the right to be skeptical? So what's our answer?
No.
Nope.
Not even close.
Yeah, go give somebody a rabies shot or something. No, our sample data. Support that the proportion of crazy people is about 0.37. Or you could say, you could just say, no, the veterinarian does not have the right to be skeptical. And that's answering the question. Okay? So if we go back and do this as a hypothesis test,
Yeah.
okay? What are we gonna expect with a p-value? Let's talk about that real quick. So we did not reject HO.
It should be bigger than alpha.
It should be bigger than alpha, right? The p-value should be bigger than alpha. It should be, and I think if the established proportion is really, really close to either boundary, you might get kind of a,
Close.
yeah, you might get kind of a, one of those variable, or those, what do I want to say? Those debatable p-values, okay, not a strong result either way. But I think we're going to get a pretty, I think we're going to get a p-value that's probably bigger than 10%. That's my guess. Okay, so let's go to one prop z-test. And the established proportion is 0.37, right? Yeah. And we've got 54 successes in 150 trials. Be sure to select the correct alternative. And there we go. Oh my God, look at that p-value. 0.798? 0.780, right?
Yeah.
0.780. So there's a 78% chance that we get a value more extreme than the one we got. So with a p-value like that, it's really, really strong evidence in support of HO. Right? Means that test statistic is only negative. It's only 0.25 standard deviations below the mean. Really close. Charlie?
No, it's Paul.
Paul?
So our HO of P was 0.37, how come it's, I don't understand, what's the P equals 0.8?
That's
What's the point estimate in Z? 0.36, right?
That's the P.
that's p-value.
Oh, in there?
Yeah, so this is p hat. So this is the p-value of the test. So it's the probability beyond the test statistic. Okay? Then you got p hat, which is x over n.
Yeah.
Okay? That's the sample value. In other words, it's within 80% of sample values that we would expect. Does that make sense?
The two extremes are,
No,
everything
no,
else will
no.
be within that?
The p-value is saying that the value we got is within 80% of values that we would expect.